Alright, so I'm going to be working this torque quiz and seeing if I can give a little bit of help to get you ready for the test. At least that's the game plan. Okay, so we know that it says if the torque required to loosen a nut on a wheel of a car has a magnitude of 50 Newton meters, so there's our torque. What minimum force, so we're looking for F, must be exerted by a mechanic at the end of a 30 centimeter wrench. So the torque arm is 30 centimeters, but I'm going to put it in meters. So I know that torque is equal to F times R perpendicular. So if he is exerting a force like that, then this is the distance he's interested in, because there's the nut. So it tells me that it takes 50 Newton meters of torque. I'm trying to find the size of the force, and my torque arm is 0.30 meters. So I'm going to divide both sides by 0.30 meters. Those will cancel. So 50 divided by 0.3 is the same thing as multiplying 50 by 10 and dividing by 3. So that's 500 over 3. I think it's about 166.67. Now, I don't have a calculator sitting up here with me, but I'm pretty sure that that's a good number. Okay, but you've got a calculator, check it and make sure I'm not telling you a lie. All right, then it says find the magnitude of a torque. So we're looking for the value of torque produced by a force of 5 newtons. F equals 5.0 newtons. And the distance from the force to the torque arm is 25 centimeters or 0.25 meters. So if torque is equal to Fr, F is 5 newtons, R is 0.25 meters. So a fourth of 5 is 1.25. And my units are Newton meters because that's what torque is measured in. Alright, so let me get us out of this situation and move us to where I can get this quiz rolled on down. We've already done 1 and 2. Alright, so let's go back and look at number 3. Number 3 says that a 720 Newton window washer is standing, so here's my scaffold. There's a rope at each end. The scaffold is 3 meters long. And we know that the scaffold itself weighs 240 newtons. It tells you that it's uniform, so that 240 newtons is going to be smack dab in the middle. So that's 1.5 meters from each end. Because if it's uniform, the weight is considered to be at the center of the object. Center of gravity, center of mass. Okay. What is the force in each rope when the window washer stands 1 meter from the right end? So my window washer is right here. He's 1 meter from the right end, and he weighs 720 newtons. So I'm going to look at the force on the right and the force on the left. So we're going to do the force on the right first. Okay. So I have 2 unknowns, force on the right, force on the left. I'm going to get rid of one of those unknowns by putting the pivot where one of them is. So I'm going to put the pivot right there. So if this rope pulls up on that scaffold, it's going to swing in that direction. So this force on the right is going to create a counterclockwise torque. If this rope were to break, the scaffold would swing in that direction. So both of those are going to create clockwise torques. So my torque clockwise and my torque counterclockwise must be equal if that scaffold is to be straight. So torque clockwise must equal torque counterclockwise. Now be careful, these FR and another FR because you have two forces, have to equal the force on the right times R. These R's are the distance from the force to the pivot. So I have 240 newtons times 1.5 meters plus 720 newtons. Now if he's 1 meter from this end, he must be 2 meters from that end. That has to equal the force on the right. And the distance from the right end to the left end is 3 meters, the whole length of the scaffold. So now I'm going to do a little math. Well, 240 times 1.5 is 360. And again, I don't have a calculator. I'm doing this in my head, so you might need to check me. 720 times 2 is 1440. And that's equal to the force on the right, which is what I'm trying to solve for, times 3 meters. So when I add 360 and 1440, I believe that I'm going to get 1800 is equal to the force on the right times 3 meters. Both sides are going to be divided by 3 meters. So the force on the right is 600 newtons. Now I have some options. So the force on the right was 600 newtons. I can go back and rework that problem, put the pivot at the right end, and solve for the force on the left. That takes time. I don't want to do that. So really what I need to say is, well, I'm going to get rid of this gobbledygook, and then we'll talk about what to say. I want to say that these two upward forces of the rope have to equal the downward forces of the man's weight and the beam's weight. So this was 600 newtons. This was 240. And the guy weighed 720. 240 plus 720 is 960 newtons, so that's the downward force. The only upward force I know is 600 newtons, but I need 960, so I'm going to subtract 600 off of there. And that tells me that the left end is going to supply 360 newtons. Okay, so we said this was 600, and now we're going to get 360. For the one on this was our right, and this is our left. You can rework it, put the pivot down here and rework it. I promise you, you'll get 360. All right, so we're going to move on. Okay, so now we're going to try number 4. A uniform 50 Newton board supports 2 children, one weighing 610 and the other weighing 350. The support is at the center of mass, and the 610 sits from the... Okay, so let's just draw a picture. It's always great to draw a picture. Okay, if it weighs 50 newtons and it's uniform, there's a support at the center of the board. Okay, and that's where the 50 newtons would be. One of the children is 6'10". The 6'10" child sits 1.5 meters from the center. And I'm going to put this other child, and it only makes sense to me that the other child go on this side, because otherwise I'd have 2 kids over here and nothing over here, and the board would never balance. So let's go with 350 times some distance that I'm going to call x. Now, is that the only way to draw it? No, I could have put the 350 over here and the 610 over there. It doesn't matter. It's going to work the same. Okay, so the weight of the board I don't have to worry about because I put my support right where the weight of the board would be. The 610 is going to try to make the board slide in that, or swing in that direction, so that's a counterclockwise torque. The 350 would try to make it swing in that direction, so that's a clockwise torque. So torque clockwise has to equal torque counterclockwise. Okay? So if I look at that, my torque clockwise is 350 for the force. The distance is x. The counterclockwise is 610 newtons, and it's 1.5 meters away. So 610 times 1.5, well, half of 610 is 305, so that's going to be 900 and, oops, let's see if we can make that not be quite so yucky. So that's going to be 915 Newton meters. for this side. And then for this side over here, it's still going to be our 350 newtons times x. 350 newtons times x. And those are going to be equal. So both sides are going to get divided by 350. So I don't have a calculator. I'm going to be kind of winging it. So x is going to be, well, let's say 2. And that gives me 700. And it's about 2.3 meters. But you better check your calculator. Get your calculator out and make sure I'm not lying to you. But anyway, it's close enough. You can see and fix the math if you need to. Then part B says, how much upward force does the support exert on the board? Well, if the board is supported in the center, then it's got to support a force equal to the weight of the board, plus the child on the left, plus the child on the right. So if I add that up, that's 400 plus 610 is 1,010 newtons. Because the up forces have to equal the down forces. All right? So let's see what this bonus looks like. All right. So the bonus says, a 1 Newton meter stick is supported at the 40 centimeter mark by a string attached to the ceiling. 7 newtons at the 10 centimeters. Another mass is somewhere to keep it in equilibrium. Okay, so let's figure that out. That's not real hard. So we have 1 Newton, the meter stick has 1 Newton, and that weight's going to be right at the 50 centimeter mark because it's a uniform meter stick. All right. And then at the 40 centimeter mark, there's a string, has some tension in it. And we know the tension is 15.6 newtons. All right, let's see what else. Got a 7 Newton at the 10 centimeter mark. And somewhere along the meter, okay, so we don't know where the other one's going to be, but we can easily figure this out because the forces up have to equal the forces down, so that's a piece of cake. The only upward force we have is 15.6 newtons. Then we have the weight of the meter stick down, the mass, or the one that's hanging at 10 centimeters down, and then the unknown. So that gives me 8. So 15.6 minus 8 tells me that this force unknown must be whatever 15.6 minus 8 is. I think that's 7.6. All right. So somewhere I got to put a 7.6 Newton. I don't know where yet. Okay, so we're going to put, it seems like it would be needing to be over here somewhere. I don't know. We're just going to draw it in here and then we'll figure it out. Okay, so I need to figure out where I want to put the pivot. So I'm just going to pick one of these. If I put the pivot there, then I can ignore that 7 Newton force. So if that's true, then the pivot, this tension is going to cause this meter stick to swing in that direction, which is counterclockwise. This would create a clockwise torque and another clockwise torque. And everything, all my R's are measured from that pivot point. So my torque counterclockwise has to equal my torque clockwise. All right? Well, let's see. Counterclockwise is 15.6 newtons. And from the 40 centimeter mark to the 10 centimeter mark is 30 centimeters. I'm going to put it in meters. All right, and then over here I have 1 Newton weight. It's 40 centimeters away from the pivot because here's 50, here's 10, so that's 40. And then I have 7.6 newtons times some distance I'm going to call x, and I'm going to draw x in here. It's going to be the distance from here to there. All right, so 15.6 times 0.3, I'm going to do it in my head, so bear with me. That's an 8, 16, 4.68 Newton meters is equal to 0.4 plus 7.6 times x. So both sides are getting a minus 0.4, minus 0.4. Running out of space, so I'm going to go over here. So 4.68 minus 0.4 is 4.28 Newton meters, is equal to 7.6 newtons times x. I'm going to divide both sides by 7.6. So x is going to be that divided by that. Well, it's a little bit more than 50 centimeters. I know that because this is a little bit more than half of 7.6. So let me see if I can figure that out. So it's going to be 0.5. I'm saying 0.55, but again, I don't have a calculator. So get one and check me out. I don't know how good that is. But we're going to pretend that, let's see, maybe I can go over here and get a, sheesh, who knew? Okay, so 4.28. I don't know how close I am. Divided by 7.6. Ooh, 0.56. Go, Miss Walker. So there we go. All right, I hope this is some help for you. Take care of yourself, and we'll do this again sometime.